To write the inverse equation using algebra instead of graphing, we first remove the function notation. So step one is to replace f of x with y. Then you swap x and y. They trade places. And you solve for y. Once you've solved for y, then you replace y with inverse notation, inverse of f of x. I have 3 examples to work with you. First, f of x equals 3x minus 2. Step 1, replace the function notation with y. So instead of f of x, I write y equals. Then, because it's inverse, x and y trade places. So I put the x where the y is and the y where the x is, and I keep the rest of the equation the same. Now I need to solve for y. So I add 2. I get x plus 2 equals 3y. Then I divide each term by 3. So 3 over 3y is 1y. So now I've finished solving. I get y equals 1/3 x, which is another way to write x over 3, plus 2/3. Be sure not to write this as a decimal because 1/3 would have to be rounded to be written as a decimal. So we'll keep the fraction. Last step, I will replace y with function notation. So to relate this back to the original equation, I write f inverse of x equals 1/3 x plus 2/3. You can graph to check and verify that 1/3 x plus 2/3 and 3x minus 2 are symmetrical across the line y equals x. Here I have another example. F of x is 2x plus 3, all divided by 5. First, I will take off the function notation and write this as a y equals equation. Then, because I'm finding inverse, x and y change places. I'll write x equals 2y plus 3, and this is all divided by 5. I need to solve for y. My first step will be to multiply both sides of the equation times 5. If I multiply it by 5 and divide by 5, then those are inverse operations. Then I won't have a fraction on the right side. What I'll have is 5x equals 2y plus 3. To continue solving for y, I subtract 3. Now I find that 5x minus 3 is equal to 2y. And since I want to know what y equals, what 1y equals, I divide by 2. Make sure you divide each term. Now I have 2 over 2y, which is 1y. So I can write y equals 5 over 2x minus 3 over 2. When you have fractions that have 2 on the denominator. You can write them as decimals if you like to. So I'll write inverse of f of x equals 5 over 2x minus 3 over 2. This could be written as 2.5x minus 1.5. I have one example remaining. Now I have f of x equals half x minus 3. We'll use the same steps. Please work through this one and then and pause your video and then turn the video back on and we'll check and make sure that our answers agree. I'm checking in with you to see whether we agree to this point. I traded x and y. I moved this 3. Now I have half y and I need 1y, so I multiply times 2 on both sides of the equation. I'll then distribute on the left, which gives me 2x plus 6. That's equal to y. So f inverse of x is 2x plus 6. Again, you can graph the inverse equation that you found along with the original equation and y equals x, the axis of symmetry, to verify that your equations are inverse.